welcoming Dr. Johnson.
Yeah, so I guess they're different, but in order to do the data visualization, you need the data. And if you don't have data governance, you usually can't get it. So I've been spending hours over the last few days trying to look for patient-level time series data. Like, can you get patient-level data on wait times, when their appointment was, what their appointment was for? I can't get it so far. So I have local data from our own institutions that I can't use and can't give students in class, can't show you, even though I have it and it's interesting data. So that's all kind of part of the data governance process. And I wasn't quite sure what you were looking for, so we can make this interactive, and I'm happy to adjust it to what you're looking for. These are both very broad topics. So I'll just sort of jump in, and feel free to interrupt. I'd rather have a discussion than just sit up here and talk at you. So just as an overview, data governance really is a whole spectrum of things. It's the processes, methods, and technology to formally manage data and its use as an important asset. And the disclaimer here is that this is my definition. If you look up data governance, of course you'll go to Wikipedia, you'll go to other places. There's data governance organizations out there, and the definition is several pages. They kind of talk about what it is and how it's viewed. This is kind of how I see it in a concise manner. It's really all of these things. Although it's not a new concept, it's not something that's often thought about. So I'll go through kind of these 5 W's here. In terms of if you're going to do data governance, you have to start asking a lot of questions and making a lot of decisions. So there's the who questions of who's going to make and change decisions regarding the policies, methods, and technology. Who's going to be responsible or accountable for the data? Who can access the data? Who will manage the data and control or authorize or revoke access? And who will audit that process? This turns out to be a huge undertaking. It's done all the time, but often not very well because it's not thought out and you don't have the policies. So, to really do data governance, you need to start answering all these questions. And there's more. I mean, I just kind of sat down and based on my experience and what I've done and what I know, I put together a lot of the policies and the data governance structure at University of Kentucky Healthcare for an enterprise data trust. And I'll kind of show you what we did there. And it's evolving. When I put that together, I based it on work that was being done, that's been done for decades at Mayo Clinic. And I asked the person who wrote an article on that, Chris Shute at Mayo Clinic, could I get some of your policy and procedure documents? And he's like, well, I could, but they're really not ready yet. And they've done it for like 30 years. So these things are always in flux, and you just have to realize this is like any kind of user-centered design or any kind of design project. It's highly iterative. So then there's the what. What data are you going to collect? What will you give access to? At what level? It may just be types of data. It may be aggregate data. I mean, there's all these decisions. What are the organizational or personal objectives around the data? Why are you doing it? What are you doing it for? What do you need to do with the data? Oftentimes we collect data, sometimes because we have to report. We're required. Sometimes it's to improve the situation. Sometimes it's for research. And the answers to all those questions really matter. And then there's the why. Why are you collecting it? Why are you storing it? Why are you giving access to it? Right? So a lot of these are all related. And as I said, there's more. There's the when, and the main when is, when do you do it? Well, data governance is really the first thing you should do. We were able at UK Healthcare to really transform how things were being done there with respect to data. It would not have been possible at all without putting strong data governance in as the very first thing that we worked on. Because there's often when you start with this data, and I don't care whether it's for an individual researcher, a group of researchers, or an organization like a healthcare organization, or let's say a university where they've got student data, financial data, there are always data silos, and there are always people who sometimes for personal reasons, sometimes for very valid organizational reasons, are afraid to let that data go. So data, there's lots of ways to misuse and misunderstand and misinterpret data. There's lots of regulations that we have to follow for certain data, like student data or health data. And so there are serious concerns with who can use that data, who can access it, where it can be placed, how it can be used, how it can be reported. You have to get data governance in place right at the start so that you can actually start addressing those, and for large organizations where you have these data silos, so that you can assuage the concerns, the valid concerns and sometimes not very valid concerns about that data and how it's going to be used. Without that, you just get a lot of resistance and a lot of fear. So there's more things about when, right? You can think about, well, if I give access of data to someone, or if we get data, like research data, health data, student data, how long do I have to keep it? When can I get rid of it? When do I need to archive it? One of the things we often do is set up virtual machines for researchers. They're in a protected area. At University of Kentucky, we set it up so a biostatistician had access to that virtual machine. So they would VPN in securely. The researcher could get in securely. All the statistical software, visualization software that person needed and the statistician needed was on that server. Only the statistician could actually download data, and they knew they could only download the aggregate results once they had gotten the results and graphs and things that the researcher needed. When do we turn those off? Each one requires licensing. Each one takes up space. We never really answered that. It was just being done on an ad hoc basis. We had not put policies or procedures in after I was there 3 years when I'd left. Here we kind of have that, and we every year just ask, hey, are you still using this? Obviously there's a limit to what you can do there. If you get that many people signed up over time and they all keep saying we're using it, that's a problem, right? So how do you do it, and how do you pay for it? That's another issue. So lots of things to think about. Where will you store the data? Where will customers access, or stakeholders or users, right, access the data? And you have to think about physical locations and increasingly cyber locations, right? Where can they access it from? So for example, I have access to Memorial Hermann's data warehouse, but not from my office here. I have a cubicle over in Hermann TMC where I can go plug in a computer to their Ethernet and access that system. They don't have VPN set up yet. When they have VPN set up, I should be able to access it there. But I still have to watch what computer I'm using when I access that data. So all these things need to be thought about. We're now putting more and more stuff in the cloud, right? And are you putting it in a place that is secure? How are you transferring it to that place? Then the how is, how are you actually going to use people, methods, processes, and technologies to implement, to achieve whatever the answers are to those questions? How will you do that? We often start with technology because it's easy. It's something that's there, right? If an individual researcher is using Excel, I would say bad, right? Get your data out of Excel. You want to do that temporarily for something, that's fine. But we have REDCap. Right? REDCap is something they can collect data with. I don't know how secure ours is here at University of Kentucky. You could collect PHI with it. You could lock it down. You could have multiple people accessing that data. Each one had rights. So that was kind of a simple solution that both the IRB and biostatistics was knowledgeable about and were steering researchers towards. And most researchers, once they used it, were quite happy to be done sharing Excel files on a shared drive, where multiple students often were trying to update it and they were clobbering each other's changes, which is what often happens. You have no control over who does what with a shared Excel file. So let me just look at what we did. And this was enterprise-wide. So we have the Center for Clinical Translational Science, just like we have a CTSA organization here as well. I think it is even the same acronym. We had UK healthcare data on inpatient, outpatient, by the time I left, 3 hospitals, several clinics. So that's all patient-level data. The rules and regulations differ from that and everything else. We had the Kentucky Medicaid data for 7 or 8 years. We managed that data and did work for the state of Kentucky. Very, very different rules and restrictions on what you could do with that data and how you had to access that data. We also purchased a national commercial de-identified data set that crossed the country and was a large sample of patients who were commercially insured. De-identified, but de-identified according to the place we bought it from, which doesn't necessarily follow the same rules that HIPAA wants hospitals to follow or researchers to follow. So I would say it was sort of de-identified. So we had to be careful about that, because just because we had it and they said you could use it doesn't mean we could let researchers access it directly. Then there was KDOC for the Kentucky Diabetes and Obesity Clinic. There were 14 or so federally qualified health centers, and they were sending all of their data to us electronically on diabetic and obese patients, and we were collecting that, sending them back a dynamic report through using Tableau with an information visualization tool, and showing them how they kind of compared to the other clinics in the system. So all this goes into a data staging area. There's this ETL, extract, transform, load. You try to make sense of it all. It looks simple because it's a little arrow. These take years to get the data, just to get parts of the data and understand it and get it into some standard form. Even though everything goes in here, you can't integrate. It'd be great to integrate the Kentucky Medicaid data with the UK healthcare data. Can't do it. Just by law, just couldn't do it. So what we ended up with afterwards was 3 data warehouses. And I'm not even looking here. I don't even have the REDCap data, because that's project specific for research projects with their own IRB approval. And also a lot of quality improvement projects use REDCap to collect data, which is, then you can't use it for research at all, at least not initially. So, this is a very complex process, and this was the data governance that we set up that kind of led to constructing that. So there's a UK healthcare IT committee, and a lot of this was UK healthcare centric because the initial data that we started with was, the goal was really to get that healthcare data and make it available both for quality improvement for UK healthcare as well as for researchers. And it was really critical to build it. The data warehouse was built for UK healthcare, first and foremost. Because it was built for UK healthcare, researchers could access it with IRB approval or if it was de-identified. If we said we were going to build a research data warehouse, there is a chance we would have had to have consent all the patients before we moved any of their data into that data warehouse if it was specifically built for research. Instead, we built it for operational use. Because it was available for operational use, researchers could gain access without consenting patients as long as the IRB agreed that it was de-identified, or they would give a waiver of consent. So really little things that literally came down to saying why we were building this completely affected what we could do with the data and how easy it was for researchers to access the data. So that was the Healthcare IT Committee. Then we have a UK Healthcare Data Governance Committee. That Data Governance Committee was looking at all of UK Healthcare's data because on the operational side, this is true of almost every place that I think of every place that I know of for healthcare that I've had any contact with. People need data in a healthcare setting. They need to get reports, and they need them now. And they will blast requests for data out to all their friends who they think might be able to help them in the institution, and they'll get answers back. Often, they'll get different answers to the same question, and they take some of them and they report. And now you have different groups reporting the same metrics, only they're different. Exact same metrics. How many readmissions did we have? And you get 2 different answers because you got it from 2 different sources and they measured it in slightly different ways. So this was to try to get a handle on all of that, including what went into the data warehouse. So not just research, but operational and research. Then there's a data governance committee here for just the Enterprise Data Trust, which is not just the UK healthcare data, but all that other data that we talked about, which could then include the research data that researchers are collecting. And then there was a data stewardship committee, and that committee meets, initially it was every week. These others meet every month. But that committee did the day-to-day work. I mean, they were the folks that really understood the data, really understood the EDT, made a lot of the initial decisions and policy recommendations and technology recommendations that then would filter up to these committees. And it was important to filter up because this is the one that made the budget for the year. And so if you weren't on their agenda when they were budgeting, you were left out. So none of what we did at UK Healthcare would have been possible without this structure. And this was actually a new thing just before I was leaving that was changed, because it was getting awkward to have IT, and then this was EDT. There was actually no one overseeing how the operational folks use data within the hospital and clinics. These are some of our data sources and where they were at just before I left UK. This is what I put this up for. These were the stages that we came up with that every data source had to go through. And I don't mean like the UK healthcare data. I mean demographic data from UK healthcare's data. That was one stream. Okay, that took a surprising amount of time. It took months to load demographic data. And why is that? Well, demographic data is stored in many different places in healthcare systems. Because these systems, there's often multiple systems. In fact, UK healthcare had over 100 different clinical information and financial systems, over 100. And so the information's often duplicated. Even in the same system, it's often duplicated because companies have purchased other companies to build hospital information systems that have all these different components, and they don't bother kind of integrating the databases in the back end. They just start duplicating information. So you want to know the patient's age? You can get many answers. And it's odd things, like a lot of times the patient's address isn't in there. And we said, well, why are we missing so many patient addresses? And they said, well, it doesn't matter. The insurance is all that matters. That's who we bill. Right? So it's an interesting, challenging process. Ethnicity changes all the time, how they record ethnicity. So you've got you're trying to do this to get temporal data that goes back 6, 7, 8 years or more. And, how ethnicity has been encoded and what it means has changed throughout that entire time. Right? So it's a real challenge, and a lot of times you'll be through this and you'll completely get through, and then one night the next morning I get an email saying, our diagnostic code feed that runs every night died. There's an error, the system changed, now we have to go back and see what's going on and fix it. And that happens regularly as you're doing this. So this is a very, very complex process. And it's why Chris Shute at Mayo estimated that if you start at this level, for this enterprise level, that it takes 10 years. We did this on about $1 million. First it was about 1.5 million, then down to about 800,000. That was the first 2 years was 1.5 million. The second 2 was about 800,000 a year. And everyone who comes in externally who's done that said, I can't believe you've done that on that amount of money, because most places are spending $5, $10 million a year to do this. And it has to keep going. So I don't have much time because I talk too much. I sing 5 minutes. But let's talk about data visualization in the little time that I have. So what is data visualization? This is the Stephen Few, great. Go to his site, look him up, Perceptual Edge, very practical advice on how to do visualizations. I'll give you one. If you learn nothing else from this, never use pie charts. Okay? I'll give you a second free tip. Never use 3D graphs. Ever, ever, ever. No pie charts, no 3D graphs, and especially no 3D pie charts. They skew the information. It's horrible. The other tip is just don't use Excel to do graphs. Use a better tool. So data visualization is the use of visual representation to explore, make sense of, and communicate data. And I like to say it transforms data into information, right? Data is just differences that may or may not have meaning. Information is data plus meaning. It's data that actually means something. So here's the world of data visualization. The end goal is really good decisions. It's making better decisions. The immediate goal is understanding. You have to understand before you can make those decisions. The technologies are these visualization techniques and graphical presentations, activities or exploration and sense making, and as well as communication. Either communication from the data to the person using it and exploring it, or putting together visualizations that communicate a message to your audience. Information visualization is a specific kind of data visualization. So it's the use of computer-supported interactive visual representations of abstract data to amplify cognition. And it's different from scientific visualization. Right? So scientific visualization is where you basically have an image of a real object that has natural physical form. Whereas information visualization is about visualizing abstract data that does not have a natural physical form. Right? These are just sort of numbers. You can't take a camera out and take a picture of the percent of patients with hypertension. Right? I mean, I guess you sort of could get a bunch of people, but that's not quite what you're trying to represent, the bunches of people. And so information visualizations and data visualizations are always a mapping. Right? We think about representations and mappings. It's a mapping from abstract data to visual properties. And how you do that mapping will affect whether it's a useful visualization, whether someone can accurately perceive the information, or whether it will mislead them. Right? So there's the how to lie with statistics. There's also how to lie with visualizations. And a lot of visualizations that you see out there are either intentionally or most of the time unintentionally so poorly done that they are actually lying to you. And you'll never know it. So for example, here we take the country. Oh, it's just decided to go on this machine. The country is mapped to a dot. The region, Asia in this case, is mapped to a color, and you can see the color mapping code here. Asia's red. The income and life expectancy is the XY location of each dot. And then the population is the size of the dot. If I change that mapping, I change the visualization. And I can change this in a way that becomes very ineffective. So there is no right visualization. Tables are not bad. Tables can be very useful for certain things if you want to look up precise values. Sometimes that's what you want. Even if in dynamic tables where you can kind of search can be useful. You cannot pick a visualization without knowing the task that the user is looking for. The nice thing about interactive information visualization is that the user has some control over changing the visualization, so you can start doing what-ifs. You can start looking at the data in different ways, because each view will show you some new information, some new perspective, new patterns. And that's the whole point of it. It's a very powerful method. Just real quick, you're probably familiar with this. We've got exponential growth of PubMed citations. One of the things we're doing for research, in fact, it's so bad that the basic idea is specialization is no longer allowing us to keep up. Even in narrow medical specializations, we just can't keep up with the literature. Getting better, information retrieval researchers are trying to get us better lists of results. And I don't think that's going to help that much, because there's just too much. So you can get a better list, but there's still too much to read. In fact, that's like looking at this data and trying to make sense of it instead of looking at this, which is an interactive visualization of the data. So one of the things we've been working on following Schneiderman's visualization mantra, overview first, is a system called Delve, where when you search PubMed, you get, in this case, this is a mesh cloud You can also get word, bigram, trigram, and phrase clouds. We statistically extract phrases. Here's your document list. You can click here and filter the documents on what you've clicked on. This is a word tree that will literally dive into every abstract. This is, for all these abstracts, there's 500 here. We've typed fibromyalgia there, and this is everything that comes after fibromyalgia across all of the abstracts. You can hover your mouse here and get to the exact documents that that sentence appears in. So this is a research tool. This is very preliminary right now. It only has 2 years of PubMed. It is available. Our server just came in yesterday to expand this to all of PubMed. So that's some of the stuff that we're working on from a research perspective that I thought you might be interested in.